forensic etymologist that worked on case number 2018-GO-BT-1D.
When we got to the scene, we noticed the body had been dismembered and distributed in various boxes. The body was missing its head, along with all of its feet. Later in the day, the missing pieces were found in mailboxes throughout the neighborhood.
Hi, my name is Alondra. I'm a member of Smells Like Sioux Spirit. I worked the case the other day. One of the biggest concerns we had whenever we first arrived on scene was having been notified that witnesses had disrupted all the evidence, which is a problem for us because insects are disappearing evidence. So we had to get in there pretty quick. That was kind of alarming.
At every one of our crime scenes, we always try to have plenty of photos to refer back to and detailed expert sketches, as you can see from these examples.
Oh, hey there. I'm forensic entomologist Jessica Peoples. On day one, we put out equipment used to help us calculate PMI.
Hi, I'm Samantha Wicker. I'm a forensic entomologist with Sioux Spirit. Now, despite the tampering of evidence on day one, we are still managing to collect adult flies as well as some beetle specimens.
Hey Sam, why don't you explain why we were able to collect 5 days worth of data?
Well, because of the nature of the crime and the other crimes surrounding our area, the medical examiner deemed it necessary to leave the body on the scene and continue collecting evidence for 5 days in order to further assist the investigations going on.
Every day between the hours of 1300 and 1400, our team would go out to the site and collect more forensically important data. When we got back to the lab, it was my job to correctly identify adult fly species that had been collected that day. To properly identify adult fly species, you have to use a dichotomous key. A dichotomous key uses morphological characteristics of each fly that help you determine the correct species.
Let me close my collection here. After several days of collection, I was in charge of pinning, being sure that you penetrate through the right thorax of your Diptera and through your beetles. Also, I was in charge of helping identify these species by using the dichotomous key mentioned. And also labeling. It's important that you have 2 types of labels, identification labels and locality labels.
Yeah, Alondra again. I also helped identify adult flies, only because whenever we go out to collect, we have to collect such an abundance. So we have a ton of flies that we need to pin and identify. So it takes a team, right? I also was the primary one in identifying beetles. Made sure that those were also properly pinned and preserved.
So when we get back from the scene, my job was to sit down and move the fly larvae to from CAD, and I would sit down and start identifying them with the dichotomous keys. On day 2, the 17th, we actually were able to find third instar larvae, and we can easily identify that because there are 2 spiracles on the rear end that have 3 slits in them. We use the third instar because it's easiest to identify down to species with the third instar. This is important because we can see what species of fly not only have arrived at our body, but which have also started ovipositing.
Can you explain to the courtroom and the jury a little bit about forensic etymology?
Of course. Forensic entomology, also known as medical legal entomology, is basically where the world of insects and medical and legal practices overlap. So essentially we use the data we get from insects and that we know about insects and see how it can apply and help us to solve legal cases. We do that because insect development, or specifically blowflies and some beetles, their larval development is so well documented that we can apply it to real time. So whenever we find a body with insects, we can rear them and see how they grew and how long it took for them to get there, for us to estimate a day when those insects first arrived, which is very important because insects and flies are usually some of the first to arrive to a body.
What kind of research is out there to support this?
So a lot of scientists, forensic entomology has been growing, so they do a lot of research rearing them in certain temperatures to see what they like the best, in what temperatures do they grow fastest, and all those different things, and they continually watch them and record that so that all these tables concur in a way to say the egg to the first instar stage, which is one of the primary stages where they're still growing, it takes X amount of hours for a certain species. Then from the first instar to second instar, which is the second developmental stage, is X amount of hours for the same species, and so on until you pupate and then you get the fly. So we have this and we use that to calculate postmortem interval.
Ma'am, can you tell us and the jury exactly what PMI is?
Yes, I can. PMI, postmortem interval, is a calculation of insect activity to the day of discovery. I have prepared a presentation on how we get this calculation for you.
Today I'm going to be explaining how to set up and use a PMI table. Here in column A you can see we have the species labeled, which is Cochleomya macellaria. This is one of the first species that was found on our body. Column B is the date. Column C is average daily temperatures. These temperatures are imported from the nearest weather station. The nearest station to the scene of the death was less than 1 mile away. D is average daily crime scene temperatures. These temperatures are recorded using a device known as an I button that's placed at the scene after the crime. It records temperatures at 15-minute intervals, and after about a period of 5 days, the data is downloaded and we calculate averages from that. So these values are put into this table. The day of discovery for the third instar was the 17th of May. Now we don't have complete temperature data for the 17th, so we're going to use the 18th through the 22nd for both of our temperatures, and we're going to use this data to make a linear equation. Okay, now that we have our graph, we're going to insert a trend line. And you click on that trend line, and Excel will display an equation and an R-squared value for you. The R-squared value is a correlation factor. The closer the correlation factor is to 1, the stronger and more accurate our data predictions are going to be based on this equation. As you can see, we have an R-squared value of 0.936, so that's a strong R-squared value. Now, using this equation based on our data that we collected, we'll be able to predict the temperature at the scene of the death prior to our arrival. Now, we used this equation and we calculated average daily crime scene temperatures all the way until the last known day that our victim was seen. And so we have charts for May, April, and March. Okay. Column E is a baseline temperature. The baseline temperature is a temperature that is pulled from the primary literature. This temperature is according to Bird and Butler. Next, we're going to switch over to look at some notes, some other notes that you'll have from primary literature. So, for Cochleomya macellaria, the average temp of the study that we used was 25 degrees Celsius. This temperature most closely matches the temperature at our scene. The baseline temperature of the study was 5.5 degrees Celsius, as explained earlier. Then we have the hours of total time of development from the study. So you simply total those hours up to third instar, because third instar is what we identified on the body on that day that we highlighted earlier. Now we're going to use the equation accumulated degree days. So we need to convert these hours into days. As you can see here, I have done that calculation for 0.83 days. So now let's look at this equation that we're going to use that number for. So we're going to take time in days and we're going to multiply it by average minus base. That average is the average temperature from the study, and the base is at baseline 5.5. So you can see that here. We're going to do 25 minus 5.5 degrees Celsius multiplied by 4.83 days. Okay, so this gives us 94.185. This is a value based on the literature. Now, remember I told you that day of discovery was important, so we're going to go back to the graph, the Excel document for just a second. And one of these rows off to the side is some ADD. And when you use that equation to calculate your ADD, you are going to fill it into your chart here. Now your sum ADD is simply adding the ADDs together from the time that you start. Now because our victim was last seen in March, we started adding these together on our March graph. So we're going to come over here to 17th of May, and we're going to look at the sum ADD, and we have a calculation of 609.2. We're going to take that number over to our notes section, and we're going to subtract the calculated sum ADD from the literature. Now that's going to give us a value of 515.036827. And we're going to take this value and we're going to find the closest value that matches that. So the closest value to that in our sum ADD column is 514. Scroll over and see what date that is. So that gives us a day of May 12th. So this is one of our first dates for our PMI window. Now the same steps and procedures will be used for the other species that were found. The only thing that will be different is that the baseline temperatures and average temperatures depending on the literature used for those species. Based on our calculations, we have a PMI of May 12th for Cochleomya macellaria, a PMI calculation of May 9th for Phormia regina, and a calculation of May 15th for Phoenicia ceruliviridice. So all of these dates combined give us a PMI window of May 9th through May 15th.
According to your teammate's PMI date, the earliest date of insect arrival in the body is May 9th. Is there anything that could be wrong with this?
Yes, actually, that was only our initial PMI calculation before adjusting for variables. For instance, our body's rectal temperature on the first day was 22.2 degrees Celsius, colder than the ambient temperature of 23.8 degrees Celsius. According to Vygotsky, Sedan, and Williams, the core temperature being lower than the ambient isn't going to alter the speed at which the flies arrive at the carcass. It will, however, alter larval development. This is because they use the environment as a source of heat and need a higher temperature to grow efficiently. After the body's core has equalized with the surrounding environment, it will no longer be a factor in the larval development.
Colleague mentioned how coldness can affect body decomposition. Are there any other factors that would alter the postmortem interval?
Yes, there are other factors that can affect the postmortem interval, such as concealment, meaning being wrapped, buried, or any of those things that cause the body to not be exposed to air and stop or delay or alter the time at which insects arrive at the body, or that can have any effect on the pattern of succession. In our case, our corpse was found inside of several boxes. Due to this, and due to being found wrapped in bubble wrap, it can cause a delay in time in which the Calliphoridae blowflies reach the body, and with this can affect the postmortem interval that is calculated. As mentioned in Feast of Clues by Goff, 1991, a case was done of a lady who was wrapped in the blanket and found on the shore of the sea line in Hawaii. Due to her body being wrapped in the blankets, it took an additional 2.5 days for flies to penetrate through the wrapping and begin the process of decomposition.